thank you so much for coming to our tutorial, everyone, today. We got an hour talking to you about computational argumentation for fair and explainable AI decision-making system. So we really want to make it as interactive as possible. So we'll get you to chat to each other, but also put your hand up and we can ask questions throughout. If you have any comments or questions, we'd love to hear them. So just a bit about us, briefly. My name's Madeleine Waller. I'll start off the session. We have Andreas here and Elfia. Little disclaimer, Elfia has lost her voice slightly. So we hope you'll be able to hear her, and if not, we will step in and help her out. So we are also part of this thing called the Online Handbook of Argumentation for AI. And this is our little group of PhD students and early career researchers thinking about argumentation and different forms of this, specifically looking at it for AI. We run a PhD handbook as well, so take submissions, anything related to argumentation, and present this every year in a volume. And we just want to thank our colleague in Ohio, Daphne, as well, for the help with these slides. So we'll start off with a bit of a warm-up. Let's see actually what comes to mind when you think of argumentation. So there's a little Mentimeter poll if the Wi-Fi is working. It's been a bit temperamental today. Just to see what are your initial thoughts, anything that comes to mind to do with argumentation. Yeah, there's a whole row of seats at the front if people want to come sit down. You can leave at any point, even if you sit at the front. Don't worry, we're not going to scold you. It's great, lots of ideas. Lots of ideas here. Yeah, there's the code there if you want to keep adding stuff. It's also interesting for us after to see what you guys are thinking when it comes to argumentation. So yeah, the big ones, logic, debate, justification, reasoning, discussion, yeah, all exactly the kind of words we would be thinking of when we think about argumentation. Thinking some more about, yeah, the formalization, quite interesting, the argumentation theory, this idea of discourse, and I saw one about data, which has moved now, motivating someone's opinion, rationality. Yeah, so everyone's kind of thinking a lot of different things, interestingly. Usually we get a lot bigger words of reasoning and justification and everything, but people are thinking very much about different ideas. So this is going to be really interesting to explore today, actually what that means and how we can maybe formalize this in computation. So we're going to start off with a little activity. We're going to pick a debate from our lovely wheel of potential debates. And you're going to get into groups of 4. We've got a nice lot of you today, so it should be good. Groups of 4, or however many you can get in this case, and have 2 minutes just to think in pairs of an argument for. So 2 people think of an argument for, or arguments for, and 2 people think of arguments against. And then you're going to have 2 minutes to debate against the other pair and see what you come up with here. So this spin the wheel has a lot of different debates we could potentially have, so this could go very wrong depending on what it picks. We might have to respin. So let's see what debate we'll do today. Oh. Should human cloning be illegal? So we need to get into groups of 4, pick 2 people who are doing the for arguments, 2 people that are doing the against arguments, and start to come up with some arguments for this. Let us know if you need help finding a group or anything. But okay, everyone had a bit of a debate. So we'll come back to the room now. Can we have a couple of volunteers to come up to the microphone over here, just because it's online, and share some of the arguments either you made or the other pair made that you think are particularly a good argument? You don't have to believe it, we're not going to hold you accountable, but that you think is a good structured argument or any example of an argument that you've just had. Yeah?
You can essentially present my opponents, or the person who's countering me his perspective, I think it's valid, right?
Mm-hmm.
So I was essentially arguing against this. So basically, I was for legality of human cloning. So the argument that was made against my stance was What if a human clone goes out and commits some sort of a crime? Who's to be held responsible in that scenario? Is it me or the clone? Or like that opens up a Pandora's box of possibilities, essentially. And I believe that is a good argument, since I was, like, honestly, I didn't have a lot of time to think, so I could not think of a counter argument on this. But yeah.
No, brilliant. Great example of an argument, definitely. Any other ones? You don't even have to think it's good. Just any argument. Yeah, one more.
If we define human cloning as the infinite replication of the self, then it's going to exacerbate every single advantage that people have. So if you decide to clone someone who's smart, good-looking, rich, and charismatic, and you make 1 billion copies of these people, or 10 trillion copies, then everyone's going to be left behind. So you're not really going to be able to level the playing field or allow people equal opportunity to flourish in this world.
Very good, thank you. Now I'm going to make all my effort to be heard. Luckily, you can somewhat hear me. Okay, good. So, why did we ask you this? And I can't even function on the PowerPoint. Well, I've lost all my skills. So sorry, give me 1 sec. Is it? Perfect. Okay. So we've heard a couple of arguments, which could both actually be categorized as arguments from negative consequences. So you're saying cloning is bad because it might commit crimes, or cloning is bad because it might reduce accountability for crimes. This is looking at the arguments based on their content. And there is a branch of argumentation theory categorizes and analyzes arguments based on that. Another part of argumentation looks at the inner relations of a premise and a conclusion, which I'm going to explain in a minute what it means, and the interrelations. So now you were in groups. Half the people who were for something, half were against. Two arguments that are against each other is an attack relation, which is kind of the basis of the theory we're going to show you today. We start before with asking you what you thought argumentation was. What does argumentation theory bring into this very familiar, I guess, term for us? We have some definitions here to see the broadness of what an argument is. It could be a statement, it could be a reason, it could be a fact, but it would also be a course of reasoning or a discussion. So most people, I think, the first thing they think of is persuading. This is something we do a lot when the argumentation is generalized in a dialogical setting, as you just did now, or perhaps negotiate, as it's often portrayed in movies, but also, and that ties a lot to AI and explainability, argumentation is actually used a lot to explain. If you have a claim and you provide justification for it, you're at the same time explaining the statement. Sorry. Sip of water. Yes, okay. Also to deliberate. So people think of argumentation and often think of things in conflict. But actually argumentation, especially within AI, might be very useful to help us deliberate with AI. We don't need to be in conflict with each other. We might need to get to the bottom of something. We come together, we each present our arguments, our facts, what our statements are based on, and then we can come up with the best solution or the best decision. Another very relevant to AI, it's using argumentation can very well monitor the decision-making of AI systems. And lastly, also to justify, to recommend, etc., etc. Another sip of water. So, it's not just in dialogical settings, though. The mere fact that you came here today, your internal reasoning had somewhat of an argumentation. Perhaps you liked the room before and it was like cool enough and you chose to come back here, or perhaps you were very interested in argumentation, hopefully, and you wanted to see. So every information processing we really do internally uses this structure of argumentation to reason about beliefs, goals, intentions, everything internally. So if we take the simplest dilemma, do I go left or right? Then I might choose based on a specific reason that it's the fastest. Do you think of any other reasons might choose to go left over right? If anyone wants to share, you can shout. You don't have to come to the mic, I guess. I need a mic, but I think you'll be fine, maybe without it.
There's more shade on the left.
Yes, exactly. So what that does then is once you make a decision based on something, and then you come up with the reasons for it, you also kind of reveal what you care about. So perhaps you got sunburned yesterday, and by explaining why you go left or right, you reveal some more information about your life yesterday. I chose this as this is, I guess, the most common reason, and to bring in some of the terminology now of argumentation, we have I will go left, which is our statement, our conclusion, because it is the fastest route. This is the justification, or else the premise. So premise is left is the fastest route, conclusion is I will go left. And then, as I said, the reasoning, the defeasible rule that ties premise to conclusion is that taking the fastest route is the thing I care about. So why do we need argumentation, and what does it bring into the table, let's say? Well, it's very useful to model common sense reasoning, which is defeasible. Meaning you came here today assuming that the tutorial hadn't been cancelled, I presume. That's because, second bullet point here, the knowledge is often uncertain or incomplete, right? The calculation to know the exact state of the world at every single moment, it's impossible. So we make our best assumptions every time. What non-monotonic logic then brings to this is that it can be updated, and unlike classic logic, it can sustain the fallibility of the rule, the fallibility of the facts, the updates. It can model the new information, and also very often we might have inconsistent information. You know, sometimes your app says it's raining, but it's not. So you need to deal with this type of paradox in classical logical terms, I guess. So perhaps I usually go left, or today there is an obstacle, or usually I talk fine, but like today my voice won't do it. So that then in these scenarios you kind of need a framework, a logic that can model that in. And as we said before, this then internal processing can be generalized into interaction with other agents. And agents now we mean human to AI, or AI to AI system as well. And that brings us to that this generalization then of argumentation comes through dialogue, which is a very useful tool of interaction and communication. And it's a very useful tool to use with AI systems. We can think of a chatbot, I guess, but or now with the LLM explosion, this could be another case where we use a dialogue strategically and constructively enough to engage in joint reasoning with the AI systems, and also that when we are presented with a decision it can give us the justification for it in a way that we can then fact check it. Why did it make this decision? Is it because it values the value of life over the bodily autonomy, for instance, as in the abortion debate? If you have this, then you understand what the value mentality of the agent you're interacting with is. And that can help you either find some inconsistency in their thinking and reasoning, as the Socratic method does, or just provide you with more information. So that's it from me. I'll go sit over there, drink some more water.
Hello from me as well. My name is Andreas, and I'm gonna continue the talk now to a bit of a boring stuff maybe. So about the theory of argumentation, so basically formal argumentation. Some of you wrote this before when we asked you to tell us our thought of what comes to you to mind when you listen to that word. So maybe you had some insight. First of all, we will define computational argumentation as the use of computational methods and tools to construct, analyze, and evaluate arguments and the relationships between them, and in particular for aiding transparent and interactive processes, especially to decision making. So the formalization of argumentation theory has to do with using theoretical frameworks that we can then implement on computational argumentation, computational algorithms, basically, to define the acceptable arguments and acceptable decisions, basically. Computational argumentation is a recent field that emerged around the 1980s, when the first wave of researchers on AI, back then you used to call expert systems, if I'm not mistaken, tried to provide explanations for automated decision systems, and which now we call explainable AI. And we use it to support human-computer interaction, but also computer-computer interaction, or AI interaction, in order to understand the reasoning process of the agents to resolve conflicts, but also make the whole procedure more transparent. But it also deals with natural language processing, so trying to explore natural language arguments and synthesize and analyze them and how they interact with each other. So a very fundamental and essential element of computational argumentation is called abstract argumentation, and this is the definition that we give to you. Abstract argumentation focuses on the acceptability conditions to allow for certain arguments to coexist in a rational manner given the attack relationships between them. So after I analyze the relationship, the attack relationships between the arguments, I can decide what I will accept and what I will not accept. So if we go to the previous example, should I go right or left? How can I represent this? Well, if we call argument 1 going left is the fastest route, therefore I should go left. And then argument 2, today there is an obstacle to the left, and therefore I should go right. We can represent this as a graph where argument 1 is a node, as is argument 2. We will disregard the internal structure of the argument. Why? Because we want to focus on the semantics, or the acceptability of this. So now I have a graph, basically, with nodes and edges between the graphs. And now I can apply computational algorithms to decide the acceptability of these arguments. If we have a more complicated example, let's say, where the topic is the social media has been good for humanity, we might start with this statement called A1. Then someone might say social media has not been good for humanity, which is argument A2 in this case. A3 being social media can be good to find news, so we get a reason for why social media can be good for humanity, but also an argument A4 which denies this by saying we cannot verify if that news is real or not. And finally, social media puts privacy and data at risk. Now, if we formulate this into a graph, we're going to get these 5 arguments. We're going to represent it as 5 nodes. And these will be the attack relationships between them. So in the first 2, we have 2 statements that conflict in one another, so they attack one another. And then we can see that A3 attacks A2 because I have found a reason why social media has been good for humanity, so it supports A1. But then A4 attacks A3 since I'm finding a reason why this statement should be not valid. And finally, A5 attacks A1. Social media puts privacy and data at risk, so therefore it's not good for humanity, so it attacks A1. Now, using a labeling algorithm, we can define acceptability of these arguments. Now, if we follow this algorithm, it's pretty straightforward, I believe. We label as in the arguments for which all its attackers are out. So basically this means that all its attackers are not acceptable, or they have no attackers at all. So if I have nothing that attacks me, or an argument in this case, then this argument should be acceptable, as there is no reason why I shouldn't accept it in this diffeasible reasoning. Now, out is an argument, labeled if it has an attacker that it is in. So at least one argument that is acceptable attacks another argument, then that argument will not be acceptable. And then in the final case, we have the undecided arguments, where we cannot really determine whether we will accept them or not. So following this algorithm, in this very simple scenario where I have a graph with two nodes and one attack relationship, if I follow the algorithm, then A2 should be in, as nothing attacks it. And since A2 is acceptable, this means that A1 will not be acceptable. So now I can determine that I will go to the right, as there is an obstacle to the left today. And if we go to our more complex example and we follow the algorithm, A4 now and A5 are not attacked by anything, so these will be in, so these I will decide to accept them. And since these are two acceptable arguments that attack two other arguments that are not labeled yet, according to the algorithm, an argument is out if it has an attacker that is in. So A1 and A3 will be out. Yes?
Can you remind us what A4 and A5 are?
Yes, let's go back. So A4 is that we cannot verify if that news is real or not. Now A4 attacks A3, which says social media can be good to find news. So basically I say, okay, but I cannot verify whether they are good or not. I have nothing to attack my statement, so I will accept it at least for the time being until a new argument comes to play and maybe change the acceptability status of this argument. A5 respectively says that social media puts privacy and data at risk, so this is a reason why not it is good for humanity. And I accept it until another argument comes to play and maybe attack it. So if I follow the algorithm, I have my framework now, my graph, and I see that the green nodes are the ones that I'm going to accept that they are true, whereas the orange ones I will accept that they are not true, at least for the time being, until we find a new argument that will be added in the framework. So this, we call it a complete labeling, and it is a fundamental labeling where we can build on for other semantics, because sometimes we might change how strict or not we are with what we accept and what we don't. I will mention some other basic semantics in a couple of slides. But before I do, let's see another example. Suppose now that I change argument A4 and I say that I read on social media that we cannot verify whether news on social media is real or fake. This is kind of a paradox argument. So we cannot really decide whether we should accept it or not, because it has conflicting information within the argument. So if we try to abstract now from it and we create a graph again, we can see that this new argument A4 actually attacks itself. So it's a self-attacking argument. This might happen in life. And so we cannot really decide whether we will accept A4 or not. So now, if we start running the algorithm again, we will see that A4 will fall under the rule, under the third rule regarding undecidability, undecided argument. So I don't have enough information to decide whether I should accept A4 or not. And since A3 is attacked by such an argument, then A3 will be undecided as well. I cannot decide about this argument, as will A2, whereas A5 and A1 keep their original acceptability status. So basically, I know it is a bit boring, but it's a fundamental essence of argumentation, and this is where computational argumentation comes in the sense that now that I have a graph, I can apply algorithms on it, and then I can automate the decision making process, plus making it transparent as I can see the interactive relationships between the arguments, and I can see the reasons why I accepted something or I did not accept something. Okay? And finally, as I told you, there are some other semantics that are built on this complete labeling called grounded, preferred, stable, and semi-stable. I'm not going to go in detail because we don't have a lot of time, but this has to do with how strict or not we are in accepting something. And every application might have different purposes, so they might be more relaxed in accepting something, or they might be more strict, trying to find objectivity, for example. So now, if we're not going to do this right now, but if you want, you can scan the code and you can test creating this graph, this abstract argumentation framework for yourselves, and play a bit with it, add and remove arguments, apply different labelings, and see what you can get from it. And I think that's me now, right? So I'll call Maddie.
We realise we've thrown a lot of information at you.
Yes.
It's a big field. So does anyone have any questions at this point for us? We'll pause before I talk about some applications.
Yep.
Can't I flip your results just by adding an argument saying A4 is wrong or A5 is wrong? Like whatever graph you give me, I add one note that says this one is wrong.
It will change the acceptability status, yes. And
So then how could you use this in the real world to decide?
well, during a dialogue, for example, this is an interactive process, and this is a dynamic process as well. So we can see how, as we are discussing, this framework is initiated, let's say, and in the end, by analyzing it, we can decide who was right or wrong. So, for example, when you did your debate earlier, and if you had some arguments for and against your topic, or for and against each other that you used, then in the end, by analyzing this framework, you can determine what you will decide, what you will determine that it is true, valid, or acceptable according to the semantics that you have set. Yes? Yep. Sorry. Here or in the previous one? Yep.
So you said that A4 attacks A3.
Yep.
I was thinking social media can be good to find news. It's not saying it must be good. So it's saying there's a possibility that it could be good. And so A4 saying we can't verify whether that news is real or not doesn't necessarily contradict A3. It's still consistent with the fact that it can be good to find news.
Yeah, so that's interesting what you're raising now, because there is another subfield of computational argumentation that deals with arguments that are not actually structurally complete. So we cannot really determine the logical attacks between them. This subfield has to do with what we call enthymemes. These are incomplete logical arguments. Now, for the sake of the arguments, we have assumed that this is the attack relationship, but you can explore this even more. And just to come back to your question before, what you stated regarding how we perceive the text within the argument, this is also another subfield of computational argumentation that has to do with natural language processing. So it has to do with exploring, based on the words that you use, the internal structure, but also the attack relationship between the arguments.
What's the name of the first field?
It's about enthymemes. Enthymeme, it means an incomplete logical argument. So based on its internal structure, if you translate it into a logical form, you have some components missing which you need to explore to have a fully fledged argument and to be able to determine if it attacks another argument or not. But also, Argument mining is a hot field actually lately, because you're trying to extract from natural language the arguments that you can find in a text. Yep.
Yeah, so I have a question about how stable this labeling system would be. So in a given time frame, let's say we have two arguments and they both are attacking each other. I guess the chicken and the egg problem.
Yes, yes.
Like which chicken comes first because it lays the egg, because it hatches from the egg, and egg comes first because chicken lays the egg. So this brings us into a problem where the label will keep on changing.
So basically, this is where we will determine that these two arguments are undecided. So we don't have enough to determine what is right or wrong. But because argumentation is heavily founded on logic, following these rules and these algorithms, you can have, let's say, with certainty that logically something I cannot accept it, at least when it comes to logical consistency, for example. Okay, and now then we build on this when, for example, we have natural language coming in, or preferences, for example. This is also another field in argumentation, frameworks where we take into account the preferences of the individual. So then something might be undecided, but because I know that I prefer this specific argument, I will accept it no matter what. And then we can argue about preferences as well, and this can continue, you know, in a meta level. So this is just the basic concepts, and then you can build on this. But we don't have the time to present everything now. May I give the floor to Madi?
I would like to say a quick point before Madi goes on about what you said, and kind of tied to what you said as well. We talked about having multiple semantics. We basically touched upon that. When you have, let's say, just two arguments attacking each other, a complete labeling might say, which is like the strictest one, might say both are undecided. Other semantics explore case by case. What if one argument is accepted? What if the other? So in preferred semantics, for instance, you would have green A1, red A2, and then you take it from there, and then vice versa. And the general answer of what is acceptable is you would have a set of both pairs. Now, depending on the application you're using argumentation for, you might want to go stricter. If, for instance, you're using argumentation to filter claims for fraud, or I don't know, but if it's a travel agent, maybe you want to have all your options, even if they are somewhat attacked. And adding this is wrong is like the same as in everyday life, right? It wouldn't lead us anywhere if I say, well, you're just wrong, you're just wrong. Surely we could add this to the framework, but the framework is there to model what is being said, and it won't give you a solution outside of what is being said. It's a way to map the discussion.
I will touch on a couple of extensions that Andreas was kind of alluding to. So I think we had a really good example of where the social media, it didn't really attack. That wasn't quite the relationship between the arguments, right? So work on this has developed these bipolar argumentation frameworks, which essentially adds this support relationship as well. So we don't just have an attacking relationship, we have this support. So instead of having the ones attacking it can be good for humanity, you can now have arguments for supporting. And you have both attacks and supports in your frameworks. And obviously this means we need to define the labelings differently, define the semantics differently to account for this. So a brief example is, an argument is accepted only if it's directly defended or supported by arguments that themselves are already accepted. And I wouldn't think too much about that. There are lots of different kind of semantics to find these labelings about how to find the acceptability of arguments within bipolar argumentation frameworks as well. Are there any other kind of debates or arguments that you think wouldn't be able to be captured by a bipolar argumentation framework? Any thoughts of stuff you think, it would be great to be able to model that computationally?
I don't know, maybe it's a stupid idea, but it would be nice, let's say, to be able to model kind of counterfactual ways to say how can I make this argument valid, and so let's say what should I add or remove in order to make this thing.
Yeah, definitely. And there's definitely work done on that almost through the dialogue point of view as well. So thinking exactly what the next steps to the argumentation framework would be to then ensure that that argument was now valid or invalid. Yeah, definitely a really good point. Any other thoughts? Mm-hmm.
Is this framework going to support things like and or? Like if A and B are simultaneously true, then C is true. So then there's the interaction between the...
Definitely, yeah. I guess inherently it kind of tries to do this already, but yeah, there's another field called structured argumentation, which hopefully we'll have time for a quick example, but if not, come talk to us and we'll show you an example of that as well, exactly. The one I was trying to get on is what about, I think Andreas alluded to a bit of preferences and weighting to different arguments. So what if one argument is actually more important objectively than another? Maybe we weight if it comes from an evidence source, then objectively we think that's more importantly, or probably actually subjectively we think it's more important, and how we judge this. So yeah, there are more extensions of weighted argumentation frameworks and also weighted bipolar argumentation frameworks. So we can add numerical values to our graph, right? So we can add intrinsic weights assigned to our arguments, but also weights assigned to attacks and supports as well. So how important that relationship is, how strong that connection is, that attack is. Obviously, higher weights indicate stronger arguments and therefore have more influence on the final acceptability calculated. So we're looking more at equations to calculate the final acceptability of arguments, where you'd have a final weight based on how acceptable that argument is. So lots of different semantics proposed for this as well. And obviously you can imagine this gets quite complicated if you have cycles in your graph. Like the chicken egg problem, there are lots of semantics developed to try and come about this problem, but it's really difficult. You end up just not really gaining any information, right? It's an undecidable problem. So thinking about the applications, why we're all here, fact, Elfia and I especially work on argumentation in relation to safe and trusted AI. So mentioned already the interactions between computers and humans, human-AI dialogue, joint reasoning, and thinking about this explainability and transparency in decision-making. So there's a huge field of argumentation for XAI, for explainable AI, which is one of the main applications for argumentation at the moment, I would say, one of our biggest trends in Ohio. Thinking about, what's already been mentioned, solving these conflicts in multi-agent systems, and trying to provide clear and intuitive justifications for AI decisions where there may have been black boxes used for decision-making, right? So different methods for extracting information from decision-making systems and modeling them in our argumentation framework to be able to dissect the justifications and arguments. So like all explainable AI, this is kind of split into this idea of intrinsic explainability and post hoc explainability. So intrinsic being, there have been recommender systems, for example, built on argumentation. So you can see why you've been recommended this film on a platform, for example, and quite simply you can trace the logic back with the argumentation of, oh, okay, you like this actor, but you don't like this genre, and you've liked similar films, so this is why you've been recommended this film. So this intrinsic explainability. Anything I mentioned now, by the way, I'm skipping over, but if you're interested in any more resources or papers on any of this, just come to me afterwards, happy to send them over. And yes, this idea of post hoc as well, this complete or approximate. So a lot of it's approximate, very few actually, obviously complete, as with many post hoc explainability methods. So there's work done on explaining Bayesian networks using kind of argumentation abstractions. So he's thinking about the relationships between variables in data and building an argumentation framework based on that. And also approximating neural networks, multi-layer perceptrons with argumentation as well. So think tracing relationships within the neural networks and representing them as arguments. To plug a little bit of my own work, this is my own application of argumentation, essentially looking at using it for bias detection. So finding reasons why individuals have been treated differently by algorithmic decision-making systems compared to their similar individuals. So I'm looking at explanations on a very local level. So looking at an individual in the data, so this is tabular data, for example, and this is looking at 5 similar individuals defined by some notion of similarity. That's another topic entirely. And creating this weighted argumentation framework of the relationship between the attribute values in the data. And essentially, it essentially makes the attacks based on where the attribute values are conflicting between an individual and the similar individuals. And then we can use weighted argumentation semantics to figure out which is the weakest argument in the framework. And in this case, the weakest argument, the smallest final weight, is the one that contributes the most to the negative classification. Again, happy to talk about that, but I'm trying to give an overview of it. Is being developed and used for this kind of thing, and I think it's quite an interesting approach to try and really find out the reasoning behind decisions. I think we have time to go over the Dutch application. So this is the real uses in academia, but we're going to show you a real use in the real world as well.
So, 1, 2, okay, let me find it. Yes, okay. So this actually comes from this colleague of ours that we thanked originally. She's actively working on this. This is an example of the Dutch police and how they deal with claims. With claims of potential fraud. So the Dutch police, because it's too much workload to review every complaint by a human, they have a more complicated system. Actually, this is a simplified version of the framework they use of how to deal with this. So we can think of these as arguments. That's what kind of argumentation brings in. Everything is kind of modeled as an argument the same way we said before. This is part of a branch of argumentation we didn't really explain before because of shortness of time, of course. This is called structure argumentation, and it looks within the argument as well. Like abstract argumentation, we talked how we abstract from the content, we abstract from everything, and we look at attack relations. Here, it's kind of a structure argument, let's say, where we have the biggest argument at the bottom here, and other arguments that our argument is based on. So for instance, 3 factors, 3 other arguments, 3 reasons that something might presumably be fraud is if I've bought the product and it hasn't been sent, if I've paid for this product, and if I kind of fear, if I have some indication of deception. On the left here, this is an and, so I need both the item not to be delivered and to have waited for it not to have been sent, whereas for deception, either a false URL or a false website would be enough. So for instance, someone might bring in a claim saying, well, I've paid for this product, it has not been delivered, I'm looking at the URL, it seems dodgy, help. So what information can we extract? How do we plug this into our framework? Not delivered is then accepted because it's not no longer attacked, and same as the rest. I should now clarify that those are not attack relations. Of course, maybe it's clear, but because previously arrows were attacks, this is no longer the case. This is all supporting relations here. So what the system does is, okay, the information that is given to me is not substantial for me to make a conclusion. This is an undecided argument at this moment. So what it does is then it identifies the factors that are missing and goes on forward to ask the relevant questions. So I've paid for this product, Okay, is the website false? No. Okay, I need to ask more questions. I'm still not sure. How long have you waited? 4 weeks, because perhaps it was a day, so it's not enough to assume that the product was not sent. So there, just to show you on the graph, then this would answer that question there. We cannot accept this argument, but we don't really need to. Deception was directly from the false URL. So both these are accepted. Next question was about if you waited or not. 4 weeks was enough. Again, this is simplified here. that the weighted argument is now accepted, which leads us to accepting that the argument was not sent as well, and to say, presumably, this is a fraudulent transaction. That would then mean the claim goes forward. The AI at this point is not at the level to completely automate it. Hopefully, it will never be the case, but that means a human then gets to oversee and investigate further. However, an argumentation framework is very useful here, because if, for instance, I have a new argument that comes up in either different scenario or in the same dialogue further down, that it's been proven, actually, maybe I send the claim and the company replies back and says, well, actually, have delivered it, it's just that delivery has been failed. Then we have a new argument attacking. Now this is an attack relation on the not dashed arrow. At this point, we can no longer accept that the product was not sent, and the presumably fraud argument is no longer accepted. If you have any questions about this application, of course, I don't know all the details because I'm not directly working with it, but if it's something about the framework or the acceptability, I could probably answer it. Cool. So to conclude, as we said before, we are part of this online handbook of argumentation. Based on our latest submissions, we've kind of found the latest trends in argumentation research because we kind of gather submissions from PhD students, which kind of gives you an insight to what is the fresh blood coming, bringing in. Andrea, if you would like to talk about the trends for... Yes.
Okay, thank you.
Oh, okay.
So basically, we've been running this project since about 2020, so about 5 years. And we have done some statistical analysis of the PhD summaries that we have received in our project. And actually, we've seen that most of the works that we have received concern the theory, argumentation theory. So there is a lot of theoretical work going on in the PhD community of argumentation, at least from the people that have interacted with us and they have sent us a summary of their work. But there is also a big percentage in applications, which, if I'm not mistaken, this is increasing over and over the years, especially now with the explosion of LLMs and generative AI. Still, a big amount of this work is on abstract argumentation that we discussed previously regarding the semantics and labelings and algorithms to determine semantics. But also a big percentage has to do with structured argumentation, so what Elfia talked about before. There is less work. There is less work so far concerning argument mining, which has to do with also natural language processing, but still this has been increasing over the past few years. So we can see a trend going from theory to practical application and actually natural language that we didn't see as much before. And then we have some other subfields of argumentation. For example, explainable AI, you see 1/4 of the works that we have received concern explainable AI. 1/5 is for logic, but then we have other subfields like neural networks, complexity, multi-agent systems, and enthymemes. And we hope that we're progressing with this project. As I said, it's only 5 years old, so we hope that we will have even better, even more actually, summaries of PhD works that have to do with argumentation, and then we can make more valid conclusions. But these are the initial results, and actually it is interesting to see that when we compared these with one of the main conferences and argumentation called COMA, actually the numbers kind of aligned. So we have seen that we're capturing what is going on now in argumentation.
So yeah, that's it. If you have any questions or anything, there's also a form if you want to give us some feedback. We'd really appreciate it. Thank you so much for being here today. Hopefully, we've lured some people into argumentation field. I'll leave the QR code for a bit, and then I'll also rerun our LinkedIn accounts if you want to connect with us or if you have any more questions. And if anyone would like the QR of the implementation tool as well, I can go back to that. That would help you if you want yourselves to try out the frameworks, if you want to actually represent 3 or 4 arguments and their attack relations, see which one would be the accepted one. Perhaps it will help you with some personal decision making in your life. I don't know, I do it sometimes. This is us again.
And we'll put the slides on the OHI website as well at some point if anyone's interested. But yeah, feel free to get in contact about anything or ask us questions now, whenever.
We will stay here so if you have any questions. We have 2 minutes left, but even after that, we're going to be around and we can accept questions. Thank you very much, everyone.